In this video, we're going to look at the gradient of a curve and the first derivative. So we'll take a look at the first example. So we're going to find the gradient of the curve f of x equals 2x squared at the point where x equals 1. And to do that, I'm going to just go across to the writing pad and sketch that curve f of x equals 2x squared. So let's see, we've got f. And we're just going to draw maybe the curve first, so I'll go y, just a rough drawing. There's my x-axis and my y-axis, and this curve is y equals 2x squared. So it's actually going to go down, and I hope this is not looking too bad. It's not great, but we're interested when x equals 1. X equals 1. So what we do is the point P, when x equals 1, we can say y equals 2x squared, which is 2. So that we'll call that the point P. The point P is 1, 2. And to find the gradient of the curve at the point P, this is without using the first derivative, just by sketch. We'll really be getting an estimate. So we're going to take the point Q. The point Q, we're going to make it very, very close to P. So let's just say the value of x will be 1.001. So the point Q is so close to P, it approximates really the between P and Q approximates a straight line. Of course, it's not a straight line, but the closer Q is to P, the closer approximation it is. So effectively what we're doing is finding the slope of the tangent at the point Q. So let's just look at the y value. When x is 1.001, well then y will be 2 times 1.001 squared. Whoops. 2 times 1.001 squared equals, we'll just quickly do that, 2 times 1.001 squared. So it'll give me 2.004002 002. So that's the point Q. So the point P is 1, 2. The point Q is, oops, 2.004002. So to find the gradient at the point P, we're just going to find the slope of the straight line that joins P and Q. So y2 minus y1 for 002 minus 2 all over x2 minus x1. So we end up with 0.004002 over 0.001, which will simplify down to 4.002. So it is an approximation, so we can now say that the gradient of the curve at the point x equals 1 is equal to 4, approximately equal to 4. Okay, so that's the first example of finding the gradient by sketch. Let's take a look at another example. So we're going to sketch the derivative graph dy dx, the change in y over the change of x, or f dash x of the curve y equals f of x, and the function given is x squared plus 2. So sketch the derivative graph. So we're looking at the derivative graph of y equals x squared plus 2. So we want to sketch dy dx. The first derivative, or which we know is the slope of the tangent at a particular point. So let's just sketch y first, or f of x. And it's x squared plus 2, so put the x-axis here. And it's going to go a bit like this, x squared plus 2, where there's my 2, the y-intercept, and y there, x there. So that's my curve dy dx. Now when we're looking at sketching the first derivative, I'll do another axis down here. We will have dy dx. And this time I'll draw my x-axis here. Oops. So dy dx. Now what we're looking at is the curve y is it's decreasing. So the slope of the tangent when the curve is falling is all the time negative. So dy dx indicates the slope of the tangent until we get to this minimum turning point. Dy dx is the slope of the tangent at this point is 0. So we will be looking at a line that all the way here it's in the negative region until we get to the turning point, which is 0, and then the slope of the tangent increases. So the slope is all the time positive as as the curve is increasing. So what we end up with is a straight line dy dx. Now in this case the slope of our straight line is 2. Positive 2. Dy dx is 2x. So that is the sketch of the derivative graph of the curve x squared plus 2. So we'll go back and look at one other example where we're sketching a derivative graph dy dx when we're given a particular curve. So last example. Now in this example we're not given the actual function, but we're given a sketch of a function which looks very much like a cubic equation. So we want to sketch the derivative graph dy dx of the curve shown, and I'll skip across to the pad and just sketch that curve that's shown, and then we'll just look at sketching the derivative graph. So just want to move up here, so we'll start here and we'll just draw the axis first, and I'm going to do a sketch of the curve that we were shown. Looked something like this. There's a turning point, and this is just for the purposes of showing how these derivative graphs work. So it looks like a cubic equation. I have y or f of x over here, and x is here. And I'm going to be guided by how the curve is increasing as x increases, or how the curve is decreasing as x increases for my derivative sketch. So I'm going to draw my y-axis on my derivative sketch here, and my x-axis I will draw here. And what we're going to do is, maybe it would be a little, I could do it in a different color, I think. Yeah, just so as we don't confuse the two, I'm going to do, oh, no, get rid of that. Straight line down there, because that's sort of where the maximum is, the turning point, and we have another turning point here. So I think I'll do a straight line. Now this, if you were doing yourself in your copybook, would be maybe a dashed line. Just straighten that line up again, because we want to go through the turning point just to guide us. Oh, try that again. Okay, that'll just give us an indication. Okay, so if we take from this left-hand side here, the curve is increasing. So the gradient function has a positive slope. The slope of the tangent is positive all the way up until it gets to here. So we're in the positive area here. We're going to just go like this. Slope of the tangent is positive, and we stop there. So the slope is 0. And then in this area, the curve is decreasing all the way down until we get to the next turning point. The next turning point, the slope is 0, and the curve is increasing here, 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 and here. The curve is dropping, negative slope all the way down to this turning point. The vertex, it's a sketch, it's not shown very accurately. So I'm going to make this, the gradient function is positive. We should probably have, I'll just continue now. In this piece here, you can see it's convex, it's concave until it changes direction halfway between the two turning points. So halfway between the two turning points will give me where d the second derivative d2y dx is equal to 0. So the slope of this one is 0. This would be the point of inflection. It's where the saddle point or point of inflection, where the curve is actually changing direction. So you can see approximately halfway between there and there. So the dy dx is the gradient function, and as x. So that really indicates a sketch of the gradient function of the cubic that we were shown. Important things to notice is the region in which the curve y is increasing, the curve is decreasing, the stationary points, turning point here, and then the point of inflection, which is halfway between those two. Okay, so that's all for this video. Thank you for watching.